This is Note-Taking Guide 11.2 for Math 2. We're going to talk about independent and dependent events today in probability. So the first thing we need to do is decide what an independent event is. An independent event happens when one event has absolutely nothing to do with the other event. That can happen in these three ways. The two events are unrelated completely. You can repeat an event when the numbers won't change. So talking about spinners or dice, you can't just erase a number off of a dice to get a different probability. Or you can repeat the same activity, but you replace the item that was removed. For instance, if you're pulling your probabilities out of a bag of marbles, you would put the marble back in before you pull the second probability so that the probabilities can't change. When you're doing that, you're going to just multiply those two probabilities together, which is what that formula down at the bottom says to do. So here's an example of how to find the probability of independent events. It says, suppose you spin each of these two spinners. What is the probability of spinning an even number and an vowel? So they found the probability of the even number 1/2 because there's 3 evens on here out of 6, so 1/2. And then they found the probability of a vowel, which is 1 out of 5. And they multiplied those two probabilities together to get 1/10 for the probability of doing both of those things. Those things do not depend on each other. They're independent of each other. One does not make the other one occur. So they would be called independent events. The second kind of probability is dependent probability, and that happens when one probability depends on the second probability or the first probability. In other words, the results of the second event will change because of what happened first. So this would happen when you're pulling out of a bag of marbles and you keep the marble to the side and then pull another marble out of the bag. So when that happens, you find the probability of doing A and then you find the probability of doing B. You still multiply those together. But that probability would change because the number of marbles in the bag would have changed. So here's an example of a dependent event. There are 6 black pens and 8 blue pens in a jar. If you take a pen without looking and then take another pen without replacing the first, what is the probability that you will get 2 black pens? Well, the first time you pull it out, you would have 6 out of a total of 14 because the 8 and the 6 add together to be 14. So you would have a probability of 3/7. When you pull the second pen out, though, there's only 13 left in the jar. And there's only 5 left of all of the black pens, so you'd have 5 out of 13 the second time. When you multiply those two probabilities together, you get 15/91 for the actual probability of those two things happening together. So let's see whether or not these are dependent or independent probabilities by just reading them. Tossing 2 dice and getting a 6 on both of them. Well, these are independent because both dice will have the numbers 1 through 6 on them no matter what. You can't change the numbers on a dice, so they're independent. They can't affect each other. Number 2, you have a bag of marbles, 3 blue, 5 white, and 12 red. You choose one marble out of the bag, look at it, and then put it back. Then you choose another marble. Well, because you replaced that marble, the original probability would have the same number as the second probability. So these events are independent also. One does not rely on the other. Number 3. You have a basket of socks. You need to find the probability of pulling out a black sock, and then it's matching black sock without putting the first sock back. So say you have 10 socks, you pull out 1, and then you're not going to put it back, so then there's only 9 socks left in there for the second probability. Because those probabilities affect each other, that would be a dependent event. It affects the other event. Number 4, you pick the letter Q from a bag containing all the letters of the alphabet. You do not put the Q back in the bag before you pick another. Again, that first probability is going to affect the second probability, so it depends on the first probability. It is dependent. Find the probability of a jack and a factor of 12. Well, pulling a jack out of a deck of cards would be 4, because there's 4 jacks. out of 52 because there's 52 cards in a deck. Finding a factor of 12, those are numbers that will divide into 12 evenly. So 1 will divide into 12, 2 will divide into 12, 3 will divide into 12, 4 will, and 6 will divide into 12. So there's 5 numbers out of a total of 8 numbers for your probability on pulling out a factor of 12. And so then to find our total probability, we would multiply those together and let the calculator reduce it. So we would have 5 out of 104 for our total probability. On our next probability, we're going to find the probability of getting a 6, and then we're going to find the probability of not getting a 5. So the probability of getting a 6 on a dice would be 1 out of 6. The probability of not getting a 5 would be 5 out of 6. And then that would be 5 over 30, which would reduce to 1 over 6 for that probability. The last one, dependent event, finding the probability. We're going to find the probability of getting a Q and then getting a Q a second time. So the first time you would have 1 out of 26. The second time would be 1 out of 25. So you'd have 1 out of 650.